Hi, this is Shyamala Gauri, Assistant Professor in CSE Department, Rohini College of Engineering and Technology. Subject code CGS 355, Neural Networks and Deep Learning. Unit 5, Recurrent Neural Networks. The topics covered in this presentation are variants of RNNs and its applications. Introduction. A recurrent neural network is a type of neural network architecture designed to handle sequential data or data with temporal dependencies, where the current input depends on previous inputs in the sequence. Unlike traditional feed-forward neural networks, RNNs have connections that form cycles, allowing them to maintain a memory of past inputs and use this information for current predictions. This makes RNNs particularly suited for tasks like time series prediction, language modeling, speech recognition, and other problems where the order of the data matters. The key concepts are sequential data. In many real world problems, the order of data is important. For example, in natural language processing, the meaning of a word depends on the context of the words that came before it. Traditional feed-forward networks don't take the order of inputs into account. In contrast, RNNs are designed to process sequential data by maintaining an internal state that represents the history of previous inputs. Number two, recurrent connections. The main characteristics of RNN is the presence of recurrent connections. These connections allow information to flow not only from the input layer to the hidden layer, but also from the hidden layer back to itself. This feedback loop enables the network to remember information from previous time steps, allowing it to use past information to influence the prediction at the current time step. Internal memory. The memory of RNN is contained in the hidden state. This hidden state is updated at each time step based on the current input and the previous hidden state. Training RNNs. RNNs are typically trained using back propagation through time and extension of back propagation. BPTT involves unrolling the RNN through time, treating it as a feed-forward network with shared weights at each time step and applying standard back propagation to compute gradients and update weights. During training, the model's hidden states are updated as it processes each input in the sequence. After the entire sequence is processed, the gradients are computed and used to update the weights of the network. Vanishing and exploding gradients. RNNs face a challenge known as vanishing gradient problem during training. As gradients are propagated backward through time, they can either shrink to zero or grow exponentially, making it difficult to update weights correctly and causing learning to stagnate. This issue is particularly problematic when training over long sequences. To mitigate this, long short-term memory networks and gated recurrent units were introduced, which use more sophisticated mechanisms to preserve gradients and improve learning over long sequences. Variants of RNN. Vanilla RNN. The vanilla RNN is the simplest form as described above, where the hidden state is updated with a recurrent connection at each time step. It is suitable for short sequences but struggles with long-term dependencies due to vanishing or exploding gradient problem. Number two, long short-term memory. LSTMs are a type of RNN designed to address the vanishing gradient problem by using gates to control the flow of information. An LSTM consists of three gates. Forget gate decides what information to discard from the previous memory. Input gate determines what new information to add to the memory. Output gate controls how much of the memory to reveal as the output. Number three, gated recurrent unit. GRUs are another variant of RNN that simplifies the LSTM architecture. A GRU combines the forget and input gates into a single gate and has fewer parameters than on LSTM, making it computationally less expensive but still effective in capturing long-term dependencies. GRUs are sometimes preferred over LSTMs for their simpler structure and faster training. The applications of RNN are natural language processing, time series prediction, video processing, music generation. Thank you.